Here we're going to look at question 23 from the BMAT 2019 paper. In this question, we're given the slightly unusual example of a water jetpack, which is that we have a person stood on top of some platform which is connected to some water below, like the sea, by a tube here in the middle. Now water flows up the tube and then flows out of two nozzles here, and the water flows out at 15 meters per second. So we're told that our person is at a constant height here and this situation, and that in 12 seconds each nozzle ejects 400 kilograms of water. So the question then goes on to ask us what is the momentum of the water ejected by each nozzle in 12 seconds, and then it asks us what is the upward force from this ejected water on the jetpack and the person. So if you would like to have a go at answering this question yourself, then please just pause the video now before we have a go at doing it together. Okay, so to answer this question, I'm going to move over the page and keep the question up and just summarise the information we've been given. So here we have the question, the momentum of the water ejected by each nozzle in 12 seconds, and the upwards force on the jetpack. And we know that we have the water coming out of each nozzle at 15 meters per second, and that in 12 seconds each nozzle ejects 400 kilograms of water. So before actually answering this question, what we want to try and do is probably think about which equations we want to use. Hopefully it'll lend us some, or guide us in our way of thinking about this question. So we can just write down some equations that we know. Now if we think about, we're being asked about the momentum of the water, so we need to know about momentum. So what equations do we know for momentum? Well, there is one basic one, and that is just that momentum is equal to the mass of something multiplied by its velocity. So this is almost certainly going to come in useful because we've been told how much some mass of water, and we've been given a velocity of this water. What about other equations? Well, we're asked about the upward force on the jetpack, so we need to know about force. And we're probably going to have to relate this to momentum because we're working out momentum of the water in the first part of the question. So one equation which you might remember is that the force created by something is equal to the change of momentum on this something divided by the time it takes for this change of momentum to occur. So if you've not seen these triangles before, basically they're just the Greek letter delta, and what they actually mean, rather than being the Greek letter delta, is just a change. So this just means the change in p, the change in momentum, and this just means the change in time, change in t. You might also at this point want to write down F equals ma, Newton's second law, and you could totally do that, it would be perfectly reasonable, but we're probably not actually going to use that equation, so I'm just going to keep these two up for now. Let's go ahead and think about the first part of this question. We're trying to find the momentum of the water ejected by each nozzle in 12 seconds. So we're going to use our equation here of P equals mv, and we know that in 12 seconds we can work out the momentum by working out the mass of water ejected in 12 seconds. We're told we have 400 kilograms of water from each nozzle in 12 seconds, multiplied by the velocity it's moving at. So we have our 400 kilograms of water in 12 seconds multiplied by this 15 meters per second, which is going to give us a momentum of 6,000 kilograms per meters per second, per nozzle. So that's the momentum of water coming out of each nozzle. Let's then move on and consider the second part of the question, which is the upward force on the jetpack. So here, let's try and use our other equation that F equals delta P divided by delta T. So, to find this force, we need to work out the change in momentum caused against the jetpack, and we need to divide it by the time it takes for that change of momentum to occur. Now, we were told before that our jetpack is stationary. It's just moving it's in the at a stationary position. So the change in momentum of the water has to be equal to the change in momentum of the jetpack to keep it moving upwards. So the change in momentum against the jetpack is going to be just exactly the same as the change in momentum that we calculated before, but we have to remember that this is per nozzle and that there are two nozzles. So the change in momentum of our jetpack is going to be equal to 2 times this change in momentum divided by the time it takes for this change in momentum to occur. So 2 times our 6,000 kilogram meters per second divided by our 12 seconds. We can go ahead and work this out, and it should give us a force of 1,000 newtons. So if our change in momentum is 6,000 kilograms per meters per second per nozzle, and the force on the jetpack is 1,000 newtons, this is going to correspond to answer A given in the question.